Welcome. Welcome to the C Sharp introductory course. We're going to cover a lot on this course, so I hope that you stay with it. You power through. There might be some problems, some practice problems that may be a bit hard, but if you practice through and then you work on each of the things that we talk about, you will get to the end and you will be a C Sharp developer at the end of this course. Maybe not a master, but it will give you all the keys that you need to become a C Sharp developer. So I'm gonna go over the introduction for the course. We're gonna talk about what C Sharp is, what we use it for, the course structure, and also what we're gonna cover inside of this course. You can also get the material alongside with the each of the materials that we use. It will be attached to that lesson, so you can use those as well. So let's just go over what C Sharp is, because a lot of people don't, they might not know what C Sharp is, and C Sharp is not C hashtag, as you can hear me say, it's C Sharp. C Sharp is an object-oriented programming language, and it was made by Microsoft. Now, if you're familiar with Java, then learning the C Sharp language will be a lot easier for you because they have they have a lot of similarities, but C Sharp has its own uniqueness to it as well. So it runs on the .NET framework. You don't have to worry about this, but in case, let's say that after this course you wanted to try for an interview and you were asked what is C Sharp, this would be the answer that will be appropriate to give them, right? You just say C Sharp is an object-oriented programming language that was created by Microsoft and it runs on the .NET framework. Now, the very first version of C Sharp, so the initial version that was released, was in 2002. That's about 20 years ago. And it's still being maintained till this day being 2022. So, this year, I would say, and it's still being maintained. So we're not really seeing in the foreseeable future that C Sharp will go out of commission. It's still going to be used. Many people use it. And what do those people use it for? Well, that's what we're going to see right here. So what are the uses of C Sharp? Now, again, contrary to popular opinion, people don't actually think that you can use C Sharp for quite a few things. Maybe some game development or some back-end development, but you can actually do a lot with C Sharp. You have your web application development, so you can make web apps. You have your websites, you have game development, you have desktop applications, mobile applications, and much, much more. There are other things that you can do with C Sharp. VR as well can be done with C Sharp. Some things on database can be done with C Sharp. Some web services as well can be done with C Sharp. So learning C Sharp will give you, the ability to penetrate that market and start working as a developer in any of these fields if you're interested in any one of them. So that's just kind of the overview of what C Sharp is. And for this course, this is the structure of how we're going to cover this course. So the introduction is, we're just going to go through, the introduction into C Sharp, some syntax and basic logic behind it. And then we'll go into the core concepts of C Sharp, what makes C Sharp, what makes it a programming language. We're going to go through all of those things. And at the end of each of the sections that we have, there will be a practice that's given. So the practice will be focused on what we learned in that section. And all the way towards the end, we're now going to get a practice that combines all that you learned from all the previous sections to make one final product. So there will be a solution as well at the end of each of those for those that can't complete it. And don't knock yourself down if you're not able to complete these practice problems. Everyone goes at their own pace. It might take you a week. It might take you a month. It might take some people a day, a few hours, right? So don't compare yourself to the success of others. Go at your own pace, go at your own time, and you will be able to complete it and get to the end. The more you practice it, instead of just copying code off the internet, you will get so much better. So just another overview of what we will cover. So we're going to see how to set up the coding environment. We're going to see how to install it, how to set it up, how to write our Hello World application, the initial one. We'll cover variables, learn what they are, data types, operators, conditionals, functions, access modifiers, object-oriented programming, inheritance, all of those things, right? So there's a lot that we're going to actually cover, and these might seem unfamiliar to you, but by the time you go through each of the videos, you will understand at the end what every single one of these things are. So if you're ever asked outside what is a variable or what is an operator in C Sharp, you will know exactly how to answer those questions. So I can't wait to dive into the nitty-gritty with you. We're not really going to have a lot of theory since this is going to be a hands-on experience, so I would really push that you install as I'm installing and you set up as I set up and code as I code, so that you also have the same code that I have and you can also use that as reference for your practice. You can always refer back to a chapter if that's what you want. Go back to a section, rewatch it, make sure you understand that concept before moving forward. You don't have to just skim through everything. But if you already understand the beginning basics, right? You understand variables, data types, you want to skip all the way to object-oriented programming, you can do that as well. It's completely up to you. So the course is going to cover each of these in sections, and it's kind of modular. You can kind of do it. But for beginners, you would start from the beginning going all the way to the end. So let's get right into it. Now we're going to quickly go over how you can set up C# on your machine, right? So this is for Windows users because C# is made by Microsoft, so they have it set up to run on Windows, natively. We just need to have a tool to use to run that, and that will be our IDE. So we need an IDE to run it. And if you want to know what an IDE is, you can just Google that. You will see it's an integrated development environment. That's an IDE. So it allows you to write your code, and it does all of the machine translations for you. It will compile your code for you, and it will show you some syntax highlighting, and it would help you with like error handling and whatnot. We'll go over our IDE when we install it, but the IDE that we will use for this course will be Visual Studio Community because it is free. So it's fully featured, extensible, and free IDE. Now, if you want Visual Studio Pro, Enterprise, Market, those are paid softwares that you can also use. But for the sake of this course and for those that are just starting out that don't want to invest any money into it, you can just use Visual Studio Community. Now, to get this, you can go back over to Google. You can just write Visual Studio Community, and you will see that first link right there. It takes you exactly to where I was when the video started. All you do is you hit download. It's going to automatically start downloading for you, right? You download the installer really quickly, and then you set up everything. Let's just say yes, continue, and then it's now going to download the actual size. So that's about 16 megabytes. Depending on your internet speed, it might take some time, but just be patient with it. It would give you the installer, and then you'd be good to go. So this isn't actually the IDE. This is just the installer. And here we have to select what we want to install, right? So there's different options that we can choose, but we just have to pick the correct option. So if we scroll down, we can see here there's .NET development, desktop development. We have desktop development C++. We're not using this. What we're looking for is something for C#. We already saw it. I'm just scrolling around just so we can kind of look around, but we already see it. We can see right here, .NET development, .NET desktop development. This is what we want to install. So you select that, and then you see the options on the right side. You can, if you want to, select all of these options, but for the sake of this course, we don't need any of these, right? We don't need to set up an SQL server. We don't need to use the development tools for this. We don't need F#. We only need what is already selected for us, right? IntelliCode will give us our syntax highlighting. It would also give us some autofill. So IntelliCode, that means that when we're typing, if there is a keyword that the IDE knows, it would autofill that keyword for us. So you don't have to worry about anything here. Once you just select this, you can just let's see, install while downloading. You can select that option if you want, or you can just download before you install. That's completely up to you. If you want to save it to a separate, let's say you had 2 disk drives and you want to save it to a separate disk drive, you can just select change over here. If you click change, then you can select where you want it to save. Now for me, I want to save it on my C drive since that's where my SSD is, and I want everything to run really quickly. So I'm just going to select the C drive, leave it in the default where it's supposed to go, and I'm just going to hit install. Now this is going to take some time. This is something that's going to take, depending on your internet speed, could be hours, could be just minutes. For me, it's going to be a couple minutes, I believe, maybe an hour at most. But when this is done downloading, I'll get back to it, and then we can see what we need to do moving forward. All right, now that it's done downloading, it's going to automatically open up the IDE. If you had launch on download checked, it's going to open up the IDE. If it's not opened, you can just click the launch button right here. Right now, I can see that mine is already launched, and it's asking me to sign in. You can skip this. You can create an account. It's up to you. I'm going to skip this for now. And here you can set up the IDE to match your preferences, right? Do you want a dark theme, a blue theme, a blue with extra contrast, or light theme? Now, I usually develop on dark theme, so I'm going to stick to dark theme. And development settings, you can specify for Visual C#, or you can specify for general. It's kind of up to you. I'm going to go with general. I'll leave it at that. And then we're going to start Visual Studio. It's loading everything. saving our preferences, and here we have it. Here we have Visual Studio. So we can close out the installer. We don't need this anymore. We can now focus only on Visual Studio. And here we can create a new project right here. We can open a local folder. If we already had a project, we can open a project directly. We can even clone a repository. So a repository would be something like GitHub. When you write your code, you store it on GitHub so you can manage the different versions of your code. If multiple people are working on the same project, you might want it on GitHub so you can refer back to who did what at what time, merge, commits, and all of that. But we're not going to go into those. What we're going to do is just create a new project. You click create new project. We can see we have a console app. We have class library. We have all of this console app. Windows Forms, window form, WPF. There's different options, right? We have all of these different options. Now we don't have to worry about any of these different options. We're gonna go into a console app, and we're gonna create a simple console app that just says hello world, and that's what we're gonna do in the next part. Okay, so we're gonna make our first project as a C# developer, and that's going to be a console app project. So if you already have this installed, you could have maybe skipped the previous steps and you already had this installed. If you didn't and you followed along, this is the next step in the process, is to create our first console app. You select that and select next. You can go back just to say it again, select console app. If you don't see it at the top, you scroll and find console app. You select it right here, and then you click next. And in here, you can name your project. You can save your project to a specific place. You can also name the solution. So this is all up to you how you want to name it. So what I'm going to call this project is Hello World with no space. Like so. Whoops. Hello World. And we can leave place solution and project in the same directory. We can leave that unchecked. That's fine. And we just hit next. So the framework, .NET 6.0 or .NET 7.0, we leave it at .NET 6.0 and create. So this is now going to create our first C# project. It's loading, setting up all the preferences, setting up all the things that we would need. And here we have it. Here we have our very first project. Console.writeline, hello world. So if you look over on the right side, we see the Solution Explorer. If we expand this, we can see, ignoring the dependencies, we can see program.cs. Double-clicking that is going to show us this. So in case you don't see this, let's close that out. But you have this right panel right here. If you double-click on program.cs, it will show us console.writeline hello world. To run this, so to execute this, you would just click on the play button right here where it says hello world. You click play, and then it's going to analyze the build started, build completed. It opens our console application, and we can see hello world. Now remember, it launched the console because we selected a console application, and here we can see hello world. So if you followed along to this point, you can have your hello world application running as well. Well done. You have made it through the first hurdle of being a C# developer, which is to install, set up your IDE, and run your hello world application. So in the next part, we're going to get familiar with the IDE. We're going to understand where things are, how to find some things, and then we can now dive deeper into the concepts of C#. So I'll see you in the next part. Now that we have run our basic hello world using the new mode for C#, we can now go over the IDE to understand how it works, what it is, what we're looking at, so we don't really get, what's the word? We don't want to get intimidated by this IDE, because everything you see here, once you understand what it's doing or what it is, it's not as intimidating as it looks. So let's start with the right side, the Solution Explorer. So the Solution Explorer houses all the documents that are inside of your project. So right now we only have one document, and that's program.cs. So that document.cs is a .C# file. So the files will always end with a .cs extension. And that is our C# file right here that we can see, we can run, and it works as it should. We can also select this to show all the files. We have some hidden files, some binary files with debug, We don't have to worry about any of these. We have some object files. It also has this debug modes. We don't have to worry about any of these as well. We can also collapse everything. So if we had many things opened, right? And we let's say that we open all of these and oh, it's like, oh, it's too much to scroll over. We can just collapse everything. It's going to auto collapse all of them back down, and we don't have to worry about any of those. We also have sync with active document. You can ignore most of these. Switch between solutions and available views, ignoring those. You don't have to worry. If you were, let's say you had something else pop up on your Solution Explorer and you don't know what to do, you can just click on the home button and it will take you all the way back here. Now, if you scroll a little bit lower, move your mouse and not scroll, you will see it has another option for Git changes right here. So if we had our code on a repository, we can connect it to Git and we can see the changes that we made to Git on the right side. So for those of you that are familiar with Git and you're wondering, oh, how would I handle my Gits and whatnot, you can see it on this side. It's in the same pane or panel as your Solution Explorer. Now if we move a little bit to the left and at the bottom, right here we have our output panel right here. So this gives us the log of our program. It shows us what's running, what exited running, if we're running with debug mode, all of that it will show us right here. And if you were going to debug, you want to get some log information, you can see those here as well. You can also see the information on the console that displays, and we'll go over those when we're working on those points. So you don't have to worry about all of this that's loading here. As long as your console launches and you can see the information, you can go with that. Now, you might have some errors and it would display them here. That's when this comes in handy. You can look over, see what the error is. It might tell you you're missing a semicolon or your statement wasn't closed, blah, blah, blah. And then you can just use that to fix your problems. Most of the time, it would just give you a highlight on the syntax itself, but sometimes it might be a logical error or an error with a variable that is not defined properly. Then we can just see that on this side as well. If we move a little bit higher, here we have our editor, right? So this is where we can edit any file that we select. If we had multiple files, we can edit them here. So if I created a new file, I can edit that file in here as well just by double clicking on it. So there's nothing crazy about this. I can just write this is a test that I have here to test, right? It expects it to be code. It's not really code because, you know, none of that makes any sense, especially to C#, but this is where we can type, adjust, copy, paste. All of that happens in this editor right here. And then at the very top, we have our menus, right? So the menus gives us control over our IDE. We can change different things, create new projects, open new projects, edit the size of our editor, increase the font. All of those can be done on this menu. We can also add extensions. We can add some windows, some more windows. So if we don't want to see some windows, we can turn them off. If we want to see some more windows, we can turn them on as well. All of those, we can see them right here. And let's say that you wanted to customize your view, right? You selected dark theme and now you're thinking, actually, I don't like the dark theme. Well, it's in the menu here that you can change that. So I believe you go over to tools and theme, and then you can just switch it over to a blue theme. It's going to load that for you. Tools, theme, switch it over to blue extra contrast. It'll load that for you as well. Tool, theme, light theme, switches that to light, tool, theme, and I'm going to go all the way back to dark theme as well. So if you want to use your system settings, let's say that you have a dark theme set up on your computer, you can just specify tool, theme, and if you have a dark theme, it will use a dark theme for you, as you can see, but I'm just going to stick to dark in case my background changes. I don't want to blind myself at night. So that's kind of an overview of the IDE, how it works. You can run your project, right? Before we forget the most crucial part, you can run your project using this play button right here, if you remember. If you want to start it without debugging it, you can run it with this play button. If you want to start it with debugging, you run it with display button. You see the difference? So let's do that again, but a little bit slower. When I run with debug, watch what happens on the IDE. So we run that. We're in a debugging mode for a second while it was still going on until the application closes. Then we go out of debug mode. So our application closed right after it printed hello world. But if we had, we wanted to get user inputs and whatnot, application would not close and we would still be in debug mode. So we can see things that are happening. And if something goes wrong, we can see that on the debug output right there. Now, if we run it without debug mode, none of that happens. It just runs our application and then we can press any key and our application is done. So in the next part, we're going to go into actually creating a new project using the old method of C# so we can understand the core concept as to what is actually going on when we say console write line hello world. So I look forward to seeing you there. Let's get started. We're now going to cover some actual programming concepts. We're done with learning, introductions, getting used to the IDE. Now we're going to actually begin writing some code. So what we're going to cover in this chapter is variables. We're going to understand what is a variable, how we can write, declare, define our variables, and let's get into it. So we're going to create a new project. You can close out of your old project if you're still on that. Just close it out, reopen Visual Studio. You will see this screen right here. So if I close this and I search for Visual Studio 2022, it's going to open up and we see this right here. You can open the recent one or we can just go with the old, a new one. So we're going to go with a new one because I want to show you something that we missed in the Hello World application. So if I select to create a new project, console app, next. Here I'm going to call this variables, right? So variables, and ignoring this, we'll go next. But here we want to say do not use top level statements, right? So you're going to see the difference when we select do not use top level statements. I'm going to hit create. Again, it will take a few seconds, 10 to 15 seconds, and we should be on our way. Here we go. All right, it's downloading. Now, if you would look over at the editing panel right here, you will notice that there is significantly more code than there was the last time. So the last time we were using top level statements, so it has all of this already for us written but hidden away, and all we have to do is just write console write line hello world. So this is a new method of C#. We will cover a little bit of it, but it's just for you to understand the core concept. This is not that big a change. You just have to kind of get familiar with writing these. We would go over what these are in further lessons. But for now, all you need to worry about is what is inside of the main function. So for C#, it runs whatever is inside of our main function. Because we can have multiple functions, but for C# to know where to start, it starts in the main function all the time. And then we're inside of this class program, and we're inside of the namespace variable. So all of these you can just ignore and only worry about line 7, which is console write line hello world. Now we can go on to talk about variables. So what is a variable? Well, variables, you can think of them as just a container that can store values. So a container, imagine that you want to store water. Where would you store that water? You would store it inside of a cup. Now that cup is a variable, and the water in the cup is the value that is assigned to that variable. So how can we determine what a variable is? Well, a variable has a unique structure. So the structure of a variable is we have the variable type. So variable type, so the type of variable. We have the variable name. So variable type space variable name. And the variable name is equal to the variable value, like so, and then a semicolon, like so. So this is how we would be declaring our variables, right? So we have it, give it a type. So this is not a, this is just an idea of how we'll write it. When we begin to write it, you will see, but we give it a type, give it a name, and then we assign it a value. Now, what are the types that we can give to the variable? Well, variables there are multiple different variable types that we can assign in C#. We have the int. So the int variable, it holds whole numbers. So these numbers don't have decimals. They're just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can have 10, 200, 2000, blah, 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 up to you. But it holds whole numbers. So I can say int age, for example, which is always a whole number, can be 10, like that. So age is my variable, and 10 is the value that's inside of that variable. Now I can't say 10.9. You can see it already gives us a red error right here. So I'm zooming in, so I'm using control and scrolling the mouse just to make it a little bigger. So as you can see, it's giving us a red because we can't use, so right here, represents a double precision floating point number. So we should use double, but we're declaring it as an int. Now double allows for decimal numbers. So int does not allow for decimal numbers. So if we take that out, it is fine. But if we use a double, then we can assign decimal numbers like so. We also have string, which, as the name implies, will hold a string. So let's go to a new line and say string, like so. And then we can say name. So the type is string, the variable name is name, and the value is, so strings are, text characters, so a bunch of characters combined together to give us a word or a sentence, just text. They're annotated with quotations. So you use quotation and anything in here. So if I put 10, this becomes a string because we're using the quotation to signify that it is a string. And then to end the statement, we use a semicolon, like so. So we have string name, and then I can say name is John Doe, like so. So we have double. We also, let's make this int to be age is 10, double. Let's say the height, since it can be 1.9 or 98. So we can say that this is 1.98 meters. And then there is one more important data type, and that is a Boolean. So a Boolean holds true or false values. So bool, let's say, is male is true. Like so, because male is true. And if it isn't male, then we can say is male is false. So these are the 4 main data types for our variables. So these are the 4 main types. We have age, we have height, we have name, we have is male. All of these, as we can see, like so. And now how can we use these variables? Well, we use these variables by just calling the variable name. So whenever we call that variable name, we're going to get the value that is stored inside of that variable. So if you look at our line 12, we have console write line hello world. Let's say that we want to display the age. We would just console write line and then pass age inside instead. So when we run it, it's going to build, it's building, it's checking, and we can see 10 is displayed right there because I'm just control C. Whoops, that's not how you do it. 10 is displayed right there because age is 10. If we want to see height, we can just do the same. Height, run it. Let's close that out, rerun. Here we go. We can see 1.98. Be sure to close the window. Let's go to name. Run. We can see John Doe. So this is how we use variables. If we want to store our hello world, we will store it inside of a string. And the string would be hello world. And then we would just say hello world. End it with a semicolon. So every time you write a statement, you end it with a semicolon. That way, C# will know that, okay, this block is done. We're finished. We have set the type, named the variable, assigned the value, done. If we don't do that, it thinks that this part is continuing that statement. So when we try to run it, we come into an error, right? So we would just, do you want to run the last successful build? No. And now here we can just put that semicolon right there. If you look at the output, it shows you the error. Let's take that out. If you looked at the output, it shows you that a semicolon is expected. So we put the semicolon, the error is gone. We run that, and now we can see John Doe because we're still using name. But if we change it to hello world and we run it, we still see John Doe. Whoops. Hello world. Okay. There we go. Rerun. And now here we can see hello world. So that's how variables work in C#. They just act as containers to store values. And each of these containers can hold their different values based on the type that you have assigned to that. So just remember that to declare a variable, you have to assign it a type, give it a name, and then you also assign a value and then end that with a semicolon. And that's how we work with variables. And then in the next parts, we're going to work on some operations on these variables. So I'll see you then. Now we understand how variables work. We understand how to create variables, how to call these variables, how to use these variables. Let us now work on some operations on these variables. All right, so we're going to do some basic arithmetic operations. So like adding, subtracting, multiplying, and we're going to learn some that you may not be familiar with, which is the modulus, increment, and decrement operators. So those mainly work on number types. So that would be our int, our bool, our int, our double, our float. It doesn't work with our strings or our bool. So let's say sample like this. Whoops, has to be double quotes, like so. All right, so let's switch it over. There we go. So now we're gonna start with, the basic arithmetic operators, which is addition. So let's say that I had int egg, let's say John's eggs is 10, and then int Ella's eggs is 5, right? So we have now two variables, each of them holding unique values. We can do basic operations on these variables. So we can say, oh, I want to know the total eggs, so that would be John's eggs plus, just using the plus sign, Ella's eggs. So this is going to give us, so you can guess it, 15. So we can run this and we can see it gives us 15. Now, let's say that you wanted to store the value, so you want to store the results and use that result somewhere. You can do something like, so let's say you make a new variable, total eggs, make this equal to John's eggs plus Ella's eggs. So John's eggs, John's eggs plus Ella's eggs. So this is IntelliCode code that I'm using. It's autofilling it for me because it knows that, oh, I just want to add these two together. And now here, I can just say total eggs like this. So now when I run it, we will get the exact same value, 15. All we're doing is just assigning the value of total eggs to be equal to the addition of John's eggs and Ella's eggs. Now we can also do the same with subtraction. We can say that we want to get, let's say, eggs remaining. So eggs remaining, we run that, we will see it's 5 because we can go 10 minus 5. So plus, minus, pretty straightforward. But let's say you wanted to multiply. You can't use x, right? We can't use x to multiply. What we use is the asterisk sign. So this asterisk right here. So we can say sum of eggs. And now here we can go with sum of eggs. And we go 10 times 5, which is 50. And then we can also do the same with division. So just use the dividing symbol right there. And then we can say division of eggs. And then division of eggs. Run that. We can see that that is 2 because 10 divided by 5 is 2. Now, do note that I'm naming all of these, like I am intentionally naming these like the names that they are so that we can get into the habits of naming our variables to be relevant to what they are. Most of the time you would see code that looks like int a equal to 5, int b equal to 67 and all of that, but we don't know what a is or what b is, right? Because they're not relevant to what we're writing. But for us, we want to get into the good habit of naming our variables what they are supposed to be. That way, when we come back to it, we understand what we did before, what that variable is, what it's holding, what it's supposed to hold. We can see the type and things like that. So it's just a good habit to get into. Now we can go into other operators. So there is the modulus operator. So the modulus operator, it uses the percent symbol. So like so. What this does is it gives us the remainder of John's eggs divided by Ella's eggs. So I'm going to run this and you'll see. So we can see that's 0 because when you divide 10 by 5, there is nothing remaining, right? Because 5 can divide 10 twice. But if we said 4, for example, right? What do you think the answer would be? Let's see. We get 2 because 10 divided by 4, you would have 2, but you would remain 2, right? Because 10 would divide, because 8, so that's 2 times, and then you have 2 as a remainder. So if you want to get what is left after your division has happened, you would use the modulus operator. So it returns the remainder when the division has been, carried out. So that's one. It's very crucial because sometimes you want to just get the remainder using some maybe complicated math logic. You want to use the remainder. You would use the modulus to get that remainder instead of using a division and then finding, okay, what comes after the decimal, all of that. Just use the modulus operator, and then you can get what is left after the division operation has been carried out. We now also have the increment and decrement operators. Now they're both interchangeable in terms of depending on what you want to use them for. But what the increment operator does is it increases the value of whatever we are incrementing by just 1. And then it also, the decrement operator decreases the value by just 1. So what that means is if I said, okay, John's eggs plus plus, for example. So John's egg plus plus is an increment operator, so it should increase John's eggs value by 1. So now I'm gonna run this and let's see if you can guess what the output would be. So right now we have 10. If we run it, you still see 10. But you might be wondering, oh, but it's supposed to increase the value. Why isn't it increasing the value? That's because this operation happens after we have assigned 10 to division of eggs. If we wanted to increment this, let's put it before the assigning, so like so, and then we would now pass John's eggs as the division of eggs, right? Or we don't need this anymore. Let's just say John's eggs. When we run this, we will see 11, right? 11 right there, because the operation runs and then it displays it. If we wanted to assign this, again, let's go back to total, to be John's eggs plus plus. If we did it this way, and then we displayed the total, again, it's not going to increment because the operation hasn't run yet before the assigning has happened. The assigning happens before the operation has run. The same with decrement. If you minus minus, we want it to be 9, right? Because we are saying, okay, take John's eggs minus 1, assign it to this. If we run it, we still see 10. Because that operation will not run if you assign it this way. So if you want to increment, you would have to assign it, you would have to perform the operation before you display the value. So there is also the decrement that comes before the variable. Now what that does is it performs the operation before assigning. So if we display now, we see 9. So instead of doing it in a different line, we can just decrement or increment before assigning. This way we're saying, okay, add 1 to John's eggs before we pass John's eggs into the total. So we would do this, and it's adding 1, and then it passes it to the total. Now, do note that it is changing the value of John's egg. So if I was to display John's egg in here instead of total, we are increasing the value, meaning that this John's egg will now become 11. So as we can see here, it is becoming 11. It's not working as though we're saying, okay, John's eggs plus 1. This way, it's still 10, but total will be 11, as you can see right here. Increment and decrement operators affect the variable that it is being performed on. Don't forget that point. In case you might be wondering, oh, but I put 2, but I'm always just seeing 3. It will change the value. So this plus 1, we're just making a, an addition operation right here, right? We're just saying, okay, John egg plus 1 will be total. But if we increment, if we say John plus plus, we're saying that John's egg should be now plus 1, and then we want to assign that plus 1 to total. That's basically what we're saying. So John's egg right here would be 11, as we can see that right there. So just be careful when using the increment and decrement operators. They can be very good, but they can also be very confusing. In case you might be wondering why your variables are changing when you didn't specify a change, this would be why. So those are the operators that we can use in C#, the basic arithmetic operators. There are other operators that we will cover in future videos. So let's get to the next part. See you then. Now that we have the hang of the arithmetic operators, there are 2 other types of operators that we will go over. And it's not that complicated, but it might be a little bit tricky to wrap our heads around it. Before we go into that, let's talk a little bit about commenting in C#. So commenting is when we want to write some notes on our code, or we want to keep some feedback if we're reading someone else's code, but we don't want the compiler to execute that code as part of our statements. You know, we want to tell the IDE or tell the compiler, hey, ignore this line of code when you are compiling. We just have it as a note for ourselves. So that is a comment. So we would write a single line comment in C#, like so, using 2 forward slashes. We can see the green. That would give us a single line comment, and then we can say this is what we have here, right? So we can do another one. This is also what we have here. Now, writing comments is really good. It's really, really good practice, because you might be working on a project for maybe 3 months, right? So you begin something that you did 2 months ago. You're in the 3rd month, and now you want to look back at your previous code. If you don't have any comments anywhere, you will get lost. There might be something that was hard for you to do, and then you figured it out using maybe a hacky way, and then you want to go back to fix it, but you don't know what hacky way you did because you didn't have any notes, you didn't have any comments, so you need to be commenting your code. It's also good practice. Let's say this is where we hold our eggs. And then we can say this is the total eggs that we have in the system, right? So we can do something like that. Let's say John's eggs plus LSX. That'll be the total eggs. We can see that, and then display the total eggs to the user in the console. And there we have those comments. Now, what if we wanted to comment more than one line, right? We can just do the double slash every line that we want to comment, or we can use our multi-line comment. So let's say that this is, this is a single line comment, but we also have a multi-line comment, which is forward slash and an asterisk, like so. You can see it comments everything all the way till the end. So to end a a multi-line comment, we would end it with asterisk and forward slash, like so. So everything in here, as you can see, we can write more things. Let's say all of these, as you can see with the green, they're all comments. So this is how we would write a multi-line comment, right? So this is a multi-line comment. Whoops. Okay. Having trouble navigating. Just going to use the mouse. Multi-line comments. Just going to delete everything. There we go. Okay. So we have a multi-line comment and we have a single line comment. And that's how you can comment on C#. So now we can go into the other operators, which is our assignment operators. So what are the assignment operators? Well, the assignment operators are just operators that, as the name implies, they allow us to assign values to a variable. So let's take, for example, let's say that int age is equal to 10. And we wanted to increase what age was, right? We can say that, okay, age now, we don't need to declare the data type anymore. We can use it by just saying age. Age is now equal to 10 plus 5, right? So we can do this. We can say age is 10 plus 5. But this way is complicated, right? We want to add 5 to it, but we don't want to be pointing out the old age value like this and then put 5. We can also use the old age value by going, okay, age is now equal to whatever age value it was plus 5. We can do this. Or, again, you can age increments 4 times. So, 5 times, right? Increment it 5 times. You're adding 5 to your age. Or you can use an assignment operator. Now, what does that look like? If we want to add 5 to our age, we can use age plus equal 5. So what this does is it just says, it does exactly what the above statement is doing. We're saying age plus equal 5, as we can see up here like this. So age equal to age plus 5 is exactly the same as age plus equal 5. The same thing, the same logic applies. We can say that age is equal to age minus 5. is the same as age minus equal 5. So you get the idea. Whatever we use here, so our arithmetic operator and then an equal sign is going to be the variable plus the variable and that number right there. So I'm going to repeat. The variable plus the number will be the new value assigned to that variable. That's how the arithmetic operator works. So it might seem a little complicated. It's very similar to age plus plus is the same as, and that statement, age plus equal 1. Because age plus plus increments by 1 and age plus equal 1 just adds 1 to our age. Pardon? So this is how we can use that. It works the same way with age times equal 2. We can also do age divided equal 2. Any of the any of the operators for arithmetics, we can do it this way and convert it into an assignment operator. That way we just assign values to that variable, like so. Then there is one more type of operator that we will cover, which is the comparison operator. Now, the comparison operator usually would return us a true or false value. So this is where the Boolean comes in, right? So let's say that we have a new variable, let's say bool over 18. And this is now going to be equal to false, right? We'll start it out by being equal to false. And now we would use our comparison operator to check if the age that we have right here is over 18. How can we do that? We can say that over 18 is going to be equal to, right, age greater than 18. So if the age is greater than 18, over 18 will be true. So now we can console dot write line over 18 like so. So now we can see if the age is over 18 or not. So let's run this. And we see false because our age has gone through a lot of operations, right? So let's close this out and also display our age above. So console.writeLine, and then we're going to display the age like that. And then we're going to run this. Let's see how old we are. So we're 12 years old. So over 18 is false. If we did not divide it by 2, so we should be 24, I believe. Run it again. Nope, close that out and rerun. We're 24 and over 18 is now true. So that's what this is doing. But to convert this statement into a comparison operator, we would say over 18 greater equal 18, like so. Right? We can see that right there. Only assignments awaits can be used as a statement. Cannot be applied. Okay. Bit of a weird error. We'll go over that in a little bit. But that's how the comparison operators work. We can say another one. Let's go with bool of age equal to age is less than 18. We run that. Whoops. I have to close this. Run it again. We can see true. And then if we said of age, run that, we will see false. So that's how comments work. For multi-line comments, single-line comments, we have our arithmetic operators, which is the additions. We have our assignment operators, and then we also have comparison operators. Now that we're a bit familiar with how if statements work, switch cases work, we can move over to something a little bit more complicated, which will be our loops. So I'm going to delete most of these, and I'm going to come over here to loops. Now, what are loops? Well, in programming, loops allow us to execute a statement, a block of code, a function multiple times until we determine that it should stop. So let's say that we wanted to count from 1 to 100 and display that onto the console. We don't want to console.write line 1, console.write line 2, console.write line 3. That will get really, really tedious. What we can do is we can use a loop. What that would do is we would specify, we'll give it the control parameters, we would give it what we want it to do, and then we would let it go. We have to be very careful with loops though. If you do not use it properly, you might overuse the RAM that you have on your computer and you might crash your system. As long as you have an exit clause for your loop, so an exit clause, it's the statement that determines that your loop should stop, then your loop will stop when that statement is reached. If you do not have that, then it will have an infinite loop, and you have to be careful for that. I will show an example of an infinite loop. I would not run it. I will show you how you can have an infinite loop, but I would not recommend that you do that, because if you do that, you might come into some problems, and it's just best practice not to actually have, infinite loops, because your program will just eventually crash. So there are multiple types of loops that we have, right? We have a for loop. So let's start typing. So types, we have a for loop. We have a for each loop. We have a while loop. And in some cases, we also have a do while loop. So we're going to cover all of these different types of loops except the for each. So we're going to do the for loop in this lesson. The next lesson will be the while and the do while, and then we will have an example where we sum it together, and then we will have you working on loops. Another thing to note is that loops, just like if statements and switch cases, allow for nesting. So you can also nest loops within each other. You can have conditional statements that fire your loops, or you can have loops that fire conditional statements. It's all up to how you want to write your code. Apologies. So let's dive into the actual syntax of a loop. In this case, it will be a for loop. So let's go into for loop. Now, when do we use a for loop? Well, we use a for loop when we know exactly how many times that we want to loop through a particular, block of code. If we know that we want to execute a code 10 times, a for loop is perfect for that, because we can specify the number of times that we want it to run using our conditional statement. And we're going to go into the syntax right now. So let's say that we wanted to display a counter that counts from 0 till 5. How would we do that? Without loops, we would do it with int 1 is equal to 1, int 2 is equal to 2, int 3 is equal to 3, int 4 is equal to 4, and int 5 is equal to 5, right? And then if we want to display it, we will console write line 1, 2, 3, 4, 5. So 5 like so, 4 like so, 3 like so, 2 like so as well. We run this and we will see it's going to count 1, 2, 3, 4, 5, right? It did it for us, but this is way too many lines of code to do that. What if we decided that we wanted to count to 100? Are you going to sit and write all of these? No, you would use a for loop. And how you would do that is simple. You would write for like that. And in the for, you would have your brackets, just like the if statement, and then the code block. And everything inside this code block is what you want to run, however number of times you specify. So how do we now specify the number of times to run? Well, the for loop in here, this is what we call an argument list. It takes in 3 arguments or parameters. So in here, it's going to take 3 different arguments. The first one is the first statement that determines what we want to use as our indexer. So what that means is what object will hold the position of the loop that we're on. So if we're looping from 1 till 5, we want to know what position that we're on. So we have to declare that in the first statement. So we're going to make an integer, and we're going to just call this I, and say that I is equal to 0. Now, this first thing, it requires, right here, it requires a statement. And if it's a statement, you have to end every statement with a semicolon. Then it requires another statement. This is where we determine how many times it should run. So let's say that, okay, now we have I, which is 0. We want to loop from 0 till 5. That means that we want this loop to run whenever the next statement that we put in here, which will be a conditional logic, is true. So every time that that statement is true, we want the loop to run. So we can say, okay, if I, which is this that we just created right here, if I is less than or equal to 5. What this means is where now, first, we declare the variable I inside of the for loop, right? So this variable I is only usable within the for loop. We cannot console.writeLine I because I does not exist. I only exist within the for loop. So first we declare I, and then we specify, okay, I should be less than or equal to 5. And then we now want another statement that will eventually cause this statement to be false. So what that means is this is going to start as 0, and it's going to now check every time that I is less than 5. So I starts at 0, 0 is less than 5, this will execute. And then it's going to run the final statement. And we want it to eventually be that I would be 6, and 6 is not less than or equal to 5, therefore this loop will stop. So what will we do that will cause I to eventually become 6? Well, we can increment. We can increase the number of I. We can say, okay, I plus plus. And if you remember in earlier lessons, all that we're doing is telling I, hey, increase by 1. It's the same as saying I plus equal to 1, like so, or saying I equal to I plus 1. So any of this way works, but a quicker way to write that would just be I plus plus. So we start with, again, going over what goes in here. First, we declare the variable that we will use to know what position we are currently in that loop. The second statement is the conditional logic. Whenever this statement resolves to true, this loop will run. And then right here is our final statement, and all it does is it will eventually make sure that this does not resolve to true. So we increase I by 1 every time we run it. So the first time we run it, it's 0. When this is run, it goes back up. I becomes 1. 1 is less than 5. That's correct. It runs again. It goes back up, increases, I becomes 2. And then so on and so forth until I becomes 6. 6 is less than or equal to 5. No. Therefore, the loop will stop. So what can we do in here? Well, we can write line I. Let's now get the values that I has. We don't need this other part anymore. As you can see, to count from, well, this is going to count from 0 till 5. We only need 4 lines of code, or 1, 2, 3, 4. Yes, 4 lines of code. If you delete all the spacing, it's just 1 line of code as compared to all of these. And that's going to give you the same output, 1, 2, 3, 4, 5, as previously. So, well, it's going to have 0 as well. So 0, 1, 2, 3, 4, 5. If you wanted to start from 1, well, then you would initialize I to be 1. You run it again, and then you would have 1, 2, 3, 4, 5. What is fantastic about loops is that you can change its behavior at any time. So right now, we only want to count till 5. What if we wanted to count till 50? Well, we can just count till 50. It changes one singular digit, and here we have a count till 50. As you can see, 1 all the way down till 50. You can do the same thing with 500. Run it, and just the same way, it counts all the way till 500 without you having to rewrite that code over and over and over. It saves you so much time. And that's how a for loop works. Again, to reiterate, this part is a little bit complicated. So this is something that you would have to practice and practice until you get the hang of it. It takes 3 statements. The first statement is where you initialize your variable. The second statement is determining the condition for your loop to run. The third statement is going to make sure that this condition will eventually become false. And that can be done by incrementing or decrementing, up to you. It is all based on your logic and how you want to do it. So what we can do now is to apply another principle, which is nesting for loops together. So let's change this to 10, like so. So we only want to run this 10 times. Let's right line, and we're going to say I, like this, right? And if we run it, let's just see what we get. Okay, 1 till 10. Now, this is our, let's call it external loop. So let's say external loop, so console dot write, like so. Whoops. We're going to put a string in here. We're going to say external loop plus I. So this is just going to append the value to the string. We will go over string operations in the next section, but for now you can just copy this just to get this output. So when we play this, you will see it says, oops, or yeah, external loop 1, external loop 2, external loop 3, 4, 5, 6, 7, 8, 9, 10, you know, and so on. Now we can add another loop inside. So let's do the same way. Int j, let's name it different because we can't use I because I is already being used. Int j would be equal to 0, for example. And, well, let's just count from 1. And then we would say to j, we only want to count j 5 times, less than or equal to 5. And then j plus plus, right? And then inside of this loop, we would also write here internal loop plus j. Now, what do you think the output of this will be? Remember, I'm just going to comment. I'm just going to take this all out. Don't worry, it's going to come back. I just want to show you the previous value. So when we run this, we see external loop 1, external loop 2, 3 until 10, because this loop runs like that. But when we add an internal loop like this, where do you think the values will be appended? Do you think we'll get 1, 2, 3, 4, 5 till 10, and then it would now have internal loop 1, 2, 3, 4, 5? Or do you think it will display somewhere else? Well, let's see it. We run that, and now what do we see? We see it starts with external loop 1, and then it gives us 5 internal loops. So it first logs the external loop, and then 5 internal loops for that one, and then external loop 2, 5 internal loops for that one, and then external loop 3, and so on and so forth. Why is that happening? Well, every time that we are looping in the main loop, let's call this the outer loop. So comment, let's just say this is our outer loop. Whenever this, let's start with I. I is 1. That's true. So we come to this line. So we display external loop. Then we loop 5 times to display internal loop. That's why when I is 1, it will display external loop, and then loop 5 times to display the internal loop. And then it goes out of this loop, and then back to this loop. And then I will become 2. Then it would display external loop 2. And then it would loop 5 times, and then go out, 3, external loop 3, loop 5 times, go out, 4, 5 times, all the way till 10. That's why it displays like that. So internal loops will loop until they stop before we go back out to the external loop. So that is a concept that you have to get familiar with. It's a little tricky to wrap your head around it. But if you got it, that's wonderful. If you don't, just go back and try to understand each line what is happening. Whenever we run this loop, I is 1. 1 is less than 10. That is true. So we jump into this block. We start here, right? We display the external loop, and then we jump to this block. Oh, this is a loop. So then we go, okay, j is 1. 1 is less than 5. Yes. We jump to this. We jump out and go back here. J is 2. We don't jump out here and then jump into this. We only leave when this loop is complete. Now, there are situations where we can decide to jump out of a loop if we want to stop the loop once we reach a certain condition. That's where the conditionals can come in to be nested inside of our loops. So let's call this one, let's say, nested loops. And then I'll just comment it out. And then we can look into the break and continue keywords. So let's make another loop and say that we have int I equal to 0, and then I is greater is less than 10, right? And then I plus plus. Now we only want to display even numbers. How do we know even numbers? Even numbers are numbers that are divisible by 2. So to display even numbers, we need to check every number that's divisible by 2. To check that, we would use the modulus operator. So we would say if I, so the position that it's in right now, modulus 2, right, is equal to 0. That means that whatever I is, if you divide it by 2, it has no remainder. That means that it is even, right? So it is 10 divided by 2 is 5 with no remainder. 4 divided by 2 is 5, is 2 with no remainder. Only if I has no remainder, then we want to console.writeLine and say, and then put that number, I. So if we run this, we should only see the even numbers. So here you can see 0, 2, 4, 6, 8. If we want to make sure that it's all even, we can start with 1. We run this and we can see only 2, 4, 6, 8. Now this way we're doing it using the if, but what if we use the continue statement? Now before we use it, we need to understand what is this continue statement. So the continue right here, it tells the loop, hey, whatever you're supposed to do, I want you to skip it and go to the next iteration of that loop. So what that means is we can say console WriteLine should be right here. We don't want to put it inside the if. We're doing nothing in the if. So let's put it right there and then cut this out. If we run this, we should see every single number, right? That's correct. But we want to use the continue statement to tell it, hey, if it's not an even number, then we don't want to display this. You can use the condition with the if to display it, or you can say, okay, if I modulus 2 is not equal to 0, that means that there is a remainder. If it's not equal to 0, then we just continue like so. That means, hey, continue over to the next part. So it's not going to execute anything else. Even if we had multiple console write lines that we wanted to do, it will not execute any of those because we have said continue. So if we run this, you will see now it only gives us 2, 4, 6, 8 because the continue is telling it, hey, skip, go next. So when I is 1, 1 divided by 2 will have a remainder of 1. Therefore, it's not 0. So it's going to skip this line because of the continue right here. And then we also have the break. Now the break will stop the loop. So continue will skip over to the next step, but break will stop it completely. How does that work? Well, what if we want to stop this loop when the number is 5? So we can say if I, before we break it, let's put it in here. If I is equal to 5, we want to stop the loop. So we don't want to do anything further if I is equal to 5. So before we can see 2, 4, 6, 8, and whatnot. It's counting all the way. But now it's going to stop at 4. So let's see. and we will see 2, 4. Because once it got to 5, it's like, hey, we have to stop this loop, and then it stopped. So to see that even better, I'm going to remove the modulus check with the continue, print everything, and now we can see it's going to count 1, 2, 3, 4, 5. Okay, stop. And the loop will completely halt. That way you can jump out of a loop once you reach a certain condition. You can say, okay, I only want to check for a value. If that value is there, stop checking. And that's how we use the break and continue keyword when we're working with loops. I hope that you were able to wrap your head around that. It's a little bit tricky. Just practice and practice. Try to print from 1 to 100 using loop. And then also try, this would be a simple assignment, try to print from 100 to 1 using a for loop. So let's say practice would be print to console 100 till 1. So that's the very simple practice for for loops. I hope you can do this. If you can't, that's fine. In the next video, we will tackle it together and then we'll see exactly how we can do that while we also talk about the other loop, which is the while loop. See you then.
Subscribe us.